Okay, still working with probabilities and still working with these traits of hairline shape and earlobe shape. They say, what's the probability of having, we'll get to that in a second, from two parents, heterozygous for both traits? So mom is big W, big E, little e, and dad is the exact same way. So this is going to be one of those giant 4x4 Punnett squares because we have maximum variety in the parents. So here is our big square. Okay. Before we dig into this, there is a way that we could save time on this one using our 9331 knowledge, and I'll do that afterwards. But first, let's grind through this like we don't know anything and see what we get from the Punnett square. We have to FOIL each parent to figure out what gametes they can produce, and because they're identical, I'll just do this once. We get F means first W and first E. Big W, big E. Outside gives us big W, little e. Inside gives us little w, big E. And last gives us little. And from the other parent, we get the exact same result. Okay, and now when we cross these, we get, I'm going to type this because it goes a little faster and it's a little bit neater. Okay. I think all of those are all right. So, what does that give us for phenotypes? I suppose if I type that too, it might go a little quicker. Big W means widows, and big E means free. Wid free, and widows free. Here we get widows free, no, sorry, little e is attached. Widows free and widows attached. Big W is widow, big E is free, widows free. Little w is straight, and big E is free. Little w is straight, and big E is free. Big W is widow, big E is free. Widows, little e is attached. Little w is straight, big E is free. And here we get straight attached. Okay. Now we could count through these, and widows free, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, unsurprisingly. So 9/16 of our group is widow's peak free earlobes. Then we get, let's see, widows attached happens 1, 2, 3 times. So 3/16 is widows attached. 3 times we will get, let's see, what's the other one? Straight free. There they are. 3/16 straight free. And we get 1/16 straight attached. Now, what did it take me? 2.5-ish minutes to get through this Punnett square? We knew what these numbers were going to be, didn't we? We've seen 9331 enough times. When you have heterozygous parents like this in a dihybrid cross, this is what happens every single time. So if you're comfortable with it, you can actually skip over the Punnett square in a case like this and say, these are the probabilities I'm going to get. I know it, and I don't need the Punnett square to tell me. This 9/16 is for double dominant. You have the dominant hair trait and the dominant ear trait. The 3/16 are the two combinations where you have dominant of one thing and recessive for the other. Or here it's recessive and then dominant. And then the 1/16 is that you get the recessive trait for both things. That's the least likely case. So you can always do the Punnett square and it will come out right. But if you are okay doing this, it can save you a fair bit of work. Because in this case, in our question, they're saying, what is the chance of having a girl with straight hairline and free earlobes? Here we go. The chance of straight hairline and free earlobes is 3/16. And the extra requirement that it's a girl means roughly half of kids are girls. And the chance that they have straight hairline and free earlobes is 3/16. Top times top is 3, bottom times bottom is 32. So the probability as a fraction is 3 out of 32. As a decimal, it's 3 divided by 32, which is 0.09375. And if you multiply that by 100, you get 9.375%. So those are your fractional probability, your decimal probability, and your percentile probability.